Hey guys, so just want to make another quick video today regarding that for calculus. One is called the intermediate value theorem, and the other one is Rolle's theorem. So for the intermediate value theorem, it's about the f of x. So let's say we do have a function f of x. So it goes from negative to positive or from positive to negative. So let's say we do have an upside down parabola. So as you can see that right here, the part of the graph is negative. And then the other part of the graph is positive right here. Down here is negative. So anytime that you see the graph change the sign from negative to positive, so it's always guaranteed that there's a zero from A to B. So here's A, and here's B. And also from B to C, there's another zero right here, because that the sign changed from positive to negative. So anytime they see that f of x change the sign from positive to negative, so there's always guaranteed that there's a zero, or from negative to positive, so then that'll be a zero. And then for the Rolle's theorem, so the Rolle's theorem is showing that we do have three conditions, f of x. So for f of x, it's a continuous function on a closed interval from A to B. And then the second condition is showing that f of x is differentiable. Well, differentiable, that means once you find the derivative, the curve got to be smooth. There's no sharp turn. There's no gap right in between. There's no hole. There's no vertical asymptote. There's no jump on the open interval from A to B. And then the third condition is showing that f of A is the same as f of B. So if all these three conditions that, well, let's say that we satisfy all those three conditions, so that means we can apply the Rolle's theorem. So here's the final conclusion for the Rolle's theorem. So that means f prime of c must be 0. So let's say we do have a parabola. So this one is going this way. So if that's a parabola, so it's showing that f of a is the same as f of b. And also, obviously, it's a continuous function. There's no gap, there's no hole, there's no vertical asymptote, there's no jump right in between. And also, it's differentiable. So that means there's a point C right here down the bottom. It shows that f prime of c is 0. And also, you can do that with the upside down parabola or any kind of curve. So if that's a continuous function, differentiable, and that means there's always a zeros for f prime of c. Okay, so now let's do one example like this. So let's say that we do have y equals x squared, excuse me. So y equals x squared plus 2. So try to sketch the graph. So this one is up to unit. It's a parabola. And then the open interval, or the closed interval, so let's say that from negative 2 to 2. So for negative 2, well, first thing that I want to check is that it's a continuous function. It is. And there's no gap, no hole, so it's continuous. And also it's differentiable. If you try to find y prime, so we got 2x plus 0. Another thing that you want to check is that f of a is the same as f of b. So for f of a, we do have negative 2 quantity squared plus 2, which is 4 plus 2, then that'll be 6. And then for 2 squared plus 2, it's also the same thing. Well, because that's an even function, so that means it's symmetrical with respect to the y-axis. So we can apply the Rolle's theorem for this. So for Rolle's theorem, it's showing that f prime of c, there's a 0. So what happened if we take the derivative? So we just got this. So we got 2x equals 0. And then we solve for x. So x equals 0. So that means c is what? It's zeros right between negative 2 and 2. So that would be the Rolle's theorem. And now what about the mean value theorem, MVT? So mean value theorem is kind of similar to the Rolle's theorem. It's showing that f of x is continuous. So this one we do have two different conditions that we need to satisfy on AB, closed interval. And then f of x must be continuous. Well, must be differentiable, excuse me. On the open interval from AB. And since we can satisfy the condition, so that means we can set up that f prime of c. So that equals f of b minus f of a over the quantity of b minus a. So this one is saying that the instantaneous rate of change is the same as the average rate of change. So let's say we do have a curve going this way. So let's say that you want to find out the average rate of change between these 2 points. So basically just want to connect them. So just connect those 2 points. And then you want to find out the instantaneous rate of change. So that means there's a point right between A and B. So here's A, here's B. So let's say that there's a point C right in between, right here. And that the instantaneous rate of change, well, which is the same as the average rate of change. And back to the concept for Algebra 1 and geometry. So 2 lines are parallel, so that means the slope must be exactly the same. And that's what we're doing right now. So now let's do one example like this. So let's say we do have f of x. So let's say we do have 3x squared plus 2x plus 5. And let's say that the interval is from a to, well, so let's say that the interval is from negative 2 to 5. And now let's find out that the instantaneous rate of change in between those 2 points. So first thing that you want to check is the function is continuous. It is, because that's quadratic. And it's differentiable, so you try to find a derivative. So the derivative for this one, which is f prime of x, so 6x plus 2. Another thing that you want to find out is that f of b, f of a. So for f of b, we do have 3 times 5 squared plus 2 times 5 plus 5. So 5 squared, 25 times 3, so 75 plus 10 plus 5. So the sum, which is considered 90. And then for f of a, so a is negative 2, so we do have 3 times negative 2 quantity squared plus 2 times negative 2 plus 5. And then 3 times 4, so we got 12. And then plus negative 4 minus 4 plus 5. So for f of a, we do have 13. So now, the average rate of change, so we got 90 minus 13 divided by the difference of a and b, so 5 minus negative 2, then that'll be 7. And that equals the instantaneous rate of change, which is 6x plus 2. So 90 minus 13, so what we end up with, it's 77. And then 77 divided by 7, so we got 11. And then from here, we want to solve for x. So subtract 2 on both sides, so we got 9 equals 6x. And then x equals 9 over 6. And then once you reduce it, so that's just the value of c, which is 3 over 2. And 3 over 2, is that a point? Is that the x value right in between negative 2 and 5? It is. Then that would be the mean value theorem. So any comment, any questions that you have, so please put up on the channel. So eventually I'm going to answer all the questions that you have. Thank you.